The smooth, flowing curves of a car body are a visual delight. But each curve relies on stamping dies manufactured with micron-level precision. How do they ensure every surface of these dies is flawless? Today, we take a look at a company that leads in the field of high-end automotive cold stamping dies. And hear how they tackle this challenge.
We specialize in automotive body panels. We serve top brands at home and abroad, like Mercedes, Hongqi, BMW, Kia, Toyota, Volvo, offering one-stop solutions from die design, precision machining, to full process debugging. The automotive market is shifting to multi-models, small batches, and fast iterations. Car brands' die demands are becoming increasingly extreme. For example, a car door panel die requires key contour tolerances within plus or minus 0.2 mm. Surface quality must meet class standards. However, traditional inspection methods can't keep up with this pace. Traditionally, we rely heavily on CMMs and sample jigs. But CMM inspection is slow, taking hours or even a full day for large dies, and it can only capture discrete point data. By contrast, sample jigs lack data and rely on inspectors' experience, making precise digital tracking hard.
These bottlenecks have driven the search for new technologies, methods, and tools.
The opportunity came when we saw SCANOLOGY's 3D scanner at an exhibition. It captures complete part data in just a few minutes, which is impressive. We tested it immediately, hoping it would help overcome the last barrier in our digital manufacturing.
After introducing SCANOLOGY's SIMSCAN-S 3D scanner, it quickly became key to quality control, reverse engineering, and inspections.
Last year, we did a side panel project for an EV company. The car side panel is the largest exterior part, requiring high quality and precision. During the project, we faced a subtle wrinkling issue in the die stretching process that was hard to locate. Traditional methods would have taken at least a week, with repeated adjustments, tests, polishing, and measurements.
This time, they chose the new tool, and the efficiency improvement far exceeded expectations.
The inspector scanned the die next to the press in just 10 minutes. The software generated a deviation heat map, showing areas of material buildup from stress concentration. Our engineers then adjusted the die's stretching ribs based on the diagnostic report. As a result, the issue was resolved after just 2 adjustments. 3D scanning is no longer a nice-to-have tool. It is the foundation of digital transformation and high-end manufacturing. In the long term, it'll be a core component of digital twin factories.
From spot checks to full inspections, from experience-driven to data-driven, this company has made a breakthrough from passive debugging to precise diagnostics using SCANOLOGY's 3D scanner. In the future, they plan to integrate 3D scanning into automated production lines for real-time full inspections of key processes, together propelling China's automotive die industry toward the high end of the global value chain.